Good morning, everybody. Thank you for coming to the Dairy Forage Seminar Series. This morning, we have a speaker from the U.S. Dairy Forage Center. First, I'd like to make an announcement that the things on the chairs from Protexia has nothing to do with USDA, so it's no form of an endorsement from USDA. It's just a free giveaway that you can have. With that said, I'd like to introduce Dr. Jeffrey Zanton. Geoff was raised on a dairy farm in southern Wisconsin and earned a bachelor's degree in animal science from the University of Wisconsin in Madison. He received his PhD in dairy and animal science with a minor in statistics from Penn State University. He has worked in the feed industry managing ruminant research and development in amino acid and trace mineral nutrition. He is currently a research animal scientist with the U.S. Dairy Forage Research Center based here in Madison, Wisconsin. His current research focus is on increasing the nutritional efficiency of amino acid and protein utilization in dairy cattle. Geoff's title of his talk today is Getting the Most Out of Your Rations, Feed and Nitrogen Efficiency.
Thank you, Ken. Thank you, everybody, for coming. Can you hear me okay? Yeah, I might have to hold it here. I'll have to hold it here, I think. Thanks, everybody, for coming today. I appreciate you spending the time out of your busy day working, coming to see this presentation on how to improve feed and nitrogen efficiency and get the most out of your rations. Before I get into the talk, how many of you here know the fuel efficiency of your vehicles? Your gas mileage, how far you can get per mile of a gallon of gas? A couple people? Okay, that's something that we monitor quite frequently when we're looking at buying cars, when we're looking at how we're driving the car. But that's something that we could also look at when we're talking about feeding cows. So how many of you also know the feed efficiency of your cows or cows that you work with? Is that something that you monitor regularly? A few people, right? Well, that's something that we can monitor a little bit closer to try to understand how the cows are doing and how we're impacting our overall efficiency of the dairy. Generally, feed efficiency we think about in a couple different ways. We talk about the feed nutrients that the cow is consuming and how efficiently or how much of that nutritional component of the diet is ending up in milk, right? But this isn't a straight line going from feed to milk. Some of it has to be used for other functions in the body. First of all, we're talking about the maintenance of the cow, maintaining the body of the cow, but also the health of the cow. Activity, getting to and from the parlor, or getting up and eating some feed. And of course, we have to maintain the cow in a good reproductive state. So getting the cow bred back is always a big concern on dairy farms. So these are some things that have additional utilization of the feed beyond just making milk. We also have to take into consideration that the cows don't use all the feed that we give them. Some of them is digested relatively quickly in the rumen. Some of it bypasses the rumen and goes to the small intestines where it's digested. And once it's absorbed, it can be used to make milk, but not all of it gets absorbed. And sometimes if we're feeding cows extra nutrients, they don't use all the nutrients that we provide, and that can be excreted, either in the feces or the urine. So there's a loss of the feed nutrients as it goes through the cow, and that is what determines their feed efficiency. Now, it's not a black box anymore. I'd say that from the research perspective, we're opening up the black box a little bit, and we're starting to understand a little bit more about the control of nutrient intake, the rumen microbial population and how that contributes to digesting the feed within the rumen, the flow of materials from the rumen, and the metabolism post-ruminally. And we're also understanding a lot about the physiology of the cow and how that relates to the genetic component of the cow, the nutrient utilization of the cow. And all of these things combine to determine the portion of feed that goes into milk. And we really want to try to drive as much as possible milk nutrient production and minimize as much as possible the environmental nutrients that we're putting out into the environment. While these can be captured, the manure can be captured and have some fertilizer value, the main value that it has on any dairy farm is for the production of milk. So this is really the components of feed efficiency that we're looking at. Now, when we look at feed efficiency also, what we need to consider is this here, for our U.S. dairy producers, U.S. dollars here, and how that is impacted on the milk production side, but also on the feed side. Cheap diets aren't always most economically feasible, and making the most milk isn't always the most economically feasible. So the balance between those two components is very important. Now there's many factors that contribute to the feed efficiency on farms. The main one that we think about, at least that I think about a lot on the nutritional side, is what goes on with the cow. So we think a lot about the diet that we're providing, forage that we're providing, and forage quality. Stage of lactation, feed efficiency can vary greatly based just on the stage of lactation, whether that cow is mobilizing energy and putting that into milk, or adding energy back to her body condition in later lactation. The physical environment, and this could be related to cow comfort, heat stress, things like that. The health status of the cow, I'll touch on this a little bit later. The body weight, what is required for maintaining that cow, as well as the genetics, the genetic efficiency of that cow for producing milk. There's also some very important farm components that contribute to feed efficiency. The heifer management program, I'll touch on that a little bit, but when we feed cows, we're not only feeding the cow that is milking that day, we're also feeding cows to produce the next generation. And for a large component of the cow's life, she's actually spent in a non-productive state as a heifer. So as you would expect when you're feeding an animal and she's not producing milk, that has does not contribute favorably to feed efficiency. Feed shrink, how much we actually harvest from the field that doesn't get into the mouth of the cow, can, in the general sense on the farm, be considered a lack of feed efficiency, and then our grown feed base is also contributing to feed efficiency improvements. So if we think about on the ruminant side and dairy cattle in particular, how are we doing from a feed efficiency? This is just globally. You would say, based on just looking at the feed that goes in and the feed that comes out, you'd look and say, well, we're not doing very well, just looking at gross feed efficiency. That's based on energy or based on protein. Anywhere between 30 and 40% of the energy and protein that we're giving to cows is ending up in milk. Overall, in a gross perspective, that seems very, very poor, but if we think globally, what are we feeding the cows? Does it contribute, what are we feeding them that contributes to the overall human supply of food, right? We're feeding them to produce milk, which is a very nutritionally rich component in the human diet, but we're also feeding the cows with something that is not really usable by humans at all, or if it is, humans really don't want to eat it, okay? So we're feeding them forages, we're feeding them byproducts of industry. And if we calculate efficiency based on a human edible return, so if we take into consideration that humans don't want to eat forage, or humans don't want to eat distillers' grains really, you can see that efficiency goes up substantially. So this is a very important story that we have to tell on the dairy side, in that we're making a very nutritious food product, which is milk, from human inedible products. So over one, feed efficiency over 1 on the energy side and near 2 on the protein side. So this is a very important story that we have to tell. So this right here represents a challenge that we have to face on farm, and it's relating to return and relating to our environmental impact. But right here is a very important story that I think that we can tell, related to how we're contributing to the overall food supply for people. Whenever we balance diets for dairy cattle, we always, at least I always think of what is our foundation, what is our base, and that's always going to be the forages. So we're feeding cows based on the forage that we have either on hand or that we're able to purchase. And this is a very interesting meta-analysis that was published recently, comparing different forages and how they contribute to the productivity and feed efficiency of dairy cows. So this is based on data from the 2000s going all the way back into the 1980s. What they found was that they compared grasses and legumes. Grasses will be in blue, legumes is in red. And they looked at the intake that the cows consumed, the dry matter intake, and the milk produced. And you can see here that the dry matter intake was lower for grasses, milk production was lower for grasses than it was for legumes. Grasses had a higher digestibility than legumes, and overall there was actually no statistically significant differences in feed efficiency between grasses and legumes. So if we look at when we're feeding the different forages, they result in different outcomes from the dry matter intake and milk production, but in terms of feed efficiency, we're seeing no significant differences. And they actually broke those forages up, not just basing them on grasses or legumes, but they also broke them up into different species of forages. So perennial ryegrass, annual ryegrass, orchard grass, timothy, meadow fescue, tall fescue, and then some of the legumes, white clover, red clover, alfalfa, birdfoot, trefoil. And they actually looked at the percent of weeds in each of those. And what they saw was that when you manage the forages and you feed the forages to the cows, there was really no significant difference in feed efficiency among all of these different forages. This is across many different studies. The interesting thing was that the weeds, you saw as the weed proportion of the forages got higher, feed efficiency went lower, and also the variability in feed efficiency was quite high. So when we're talking about producing high quality forages, we want to have not only a good quality forage species present in our stand, we also want to try to eliminate or minimize as much as possible the infiltration of weeds into that forage stand in terms of optimizing feed efficiency. Now once we get past the forages, that's always going to be the base of all of our diets. However, we're going to need to supplement, in most cases, energy to the diets of the cows. And oftentimes, in the United States especially, but I think throughout the world, the way we do this is adding cereal grains to the diet of the cow. This is a meta-analysis in which the investigators evaluated the inclusion of cereal grains into diets of cows, and they found some very interesting things. The first of which was that as you increase the starch concentration of the diet, they saw a reduction in NDF digestibility, which is, I think, something that we all recognize. We're reducing the pH in the rumen, which impacts the NDF digestibility of the diet and in particular, cellulose digestibility. The really interesting thing is that although in general there was this fairly significant decline, you can see the spread of responses here. So there are ways to feed higher levels of starch within the diet, say a 25% starch, without substantially impacting NDF digestibility. So it can range anywhere between 44 and all the way up to 58% NDF digestibility. So feeding starch in such a way that we're maintaining the rumen environment, having adequate physically effective fiber to maintain total tract NDF digestibility is very important. So we want to increase the energy density of the diet, but also do that in a way to maintain the rumen environment. Now the way that it relates to feed efficiency is that what they saw was as you increase the proportion of starch in the diet, in this case they're looking at rumen digestible starch, you increase the proportion of starch in the diet, they saw reductions in milk fat concentration. So this is related again to that lower pH in the rumen, the passing of bioactive fatty acids to the mammary gland, reducing de novo synthesis of fat. They saw increases in milk protein concentration, increases in milk yield, so this is based on the equation they reported, increases in milk yield going from around 76 to 82 pounds of milk. However, when you combine this reduction in milk fat, the increase in milk protein, and even the increase in milk yield, they saw a reduction in feed efficiency by adding more cereal grains to the diet, or adding starch to the diet. And the reason for that was because over all of these experiments, they saw reduced rumen fermentation or reduced rumen environment relative to the milk fat that was produced by these cows. So if we were able to still maintain this increase in milk production while maintaining a milk fat concentration through our dietary formulation for either effective fiber or NDF, a good forage fiber in our diet, potentially we could maintain or even increase the feed efficiency while increasing milk production. Now this is also brings up an important point, is that when we talk about feed efficiency, sometimes the most feed efficient diet isn't always going to be the best diet, either in terms of overall productivity or economic return. So when you talk about feed efficiency, it's important to keep in mind that the most efficient diet isn't always the best, based on either your farm or the farm that you're working with. But it is something that we'd like to drive towards a solution in which we can increase feed efficiency while maintaining or increasing on-farm return. I'm just going to touch on this very briefly, but the reason I put this up is what we're interested in is what is secreted in milk, which is fat, lactose, and protein. And these are made by the cow from nutrients that are absorbed by the mammary gland and derived from the blood coming from the rumen. So when we think about where the fat is coming from in the milk, the majority of it is not necessarily coming from preformed fat that we would be feeding, or fat that would be mobilized from the body of the cow. A lot of that is actually coming from what's called de novo synthesis, or the construction of those milk fats from precursors derived from the rumen, such as acetate. So this would be primarily produced from fiber fermentation, for example. BHBA could be produced through starch fermentation, sugar fermentation. We also have glucose produced from propionate, which would be from carbohydrate starch fermentation, which can go towards lactose production, so this drives milk yield. But it could also go towards the production of non-essential fatty acids, or amino acids, which would go towards driving milk protein production. So what happens in the rumen impacts what is absorbed in the blood, which impacts what happens in the mammary gland. So when we think about, we're feeding these complex diets to the cows, and what we're producing is something that in effect we worry about fat, lactose, and protein in the milk. A lot has to go on in order for the diet to go from the mouth of the cow into the production of these components. And there are specific things that happen that will actually reduce the fat synthesis. So I mentioned bioactive fatty acids. These are fatty acids which escape the rumen, and they actually, not only will they show up in milk as fat, but they reduce the ability of the mammary gland to make fatty acids. So not only are we having a poor rumen environment with the pH drops, we're also allowing the escape of these fatty acids, which drop milk fat synthesis and reduce our milk fat. We can also have impacts on protein synthesis by the carbohydrate as well as the nitrogen component of the diet. So these are the results of a meta-analysis that I conducted several years ago now, where we just looked at the changing the level of crude protein in the diet, and now that impacts feed efficiency here on the right, or nitrogen use efficiency here on the left. And I'm showing here a three-dimensional plot based on the crude protein concentration would be on these axes, and days in milk here on this axis. And what you can see right away is that there's a very large impact of days in milk on the overall efficiency, both of nitrogen and of feed efficiency expressed in energy efficiency in this case. What we see in both cases is that days in milk increases, feed efficiency decreases, and nitrogen efficiency decreases. This is largely due to the mobilization of body reserves in early lactation, but also the improved efficiency of nutrient utilization in early lactation. As we increase the crude protein concentration of the diet, we see actually two competing factors occurring. As we increase crude protein, feed efficiency increases, and this can be due to increased ruminal digestibility of our carbohydrates, ruminal nitrogen availability impacts NDF digestibility, for example. However, as we increase crude protein, we see very substantial decreases in nitrogen use efficiency. So the point I'm making here is that it's very complex. We can drive feed efficiency in some cases with increasing crude protein, but if we don't know the composition of that crude protein, we can also reduce nitrogen use efficiency. So knowing the quality of the protein that you're feeding and its availability in the rumen, both of those two things together impact the nitrogen use efficiency and feed efficiency. So if we think about protein quality, cows have a requirement for protein, but not for crude protein, right? The requirement is really for amino acids. That's what's used to make milk protein, what's used to make muscle protein, etc. One of the most studied amino acids is methionine. That's expressed here as MP-methionine. What I'm showing here are the results of a meta-analysis in which we evaluated the methionine intake or the methionine flow post-ruminally and looked at milk protein production, again with days in milk as covariate. And as you can see here, milk protein yield responds dramatically to differences in days in milk. However, when we look at across days in milk, we would formulate for optimizing or maximizing milk protein yield to different levels of metabolizable methionine. So in very early lactation, we get the best results in milk protein yield from higher levels of metabolizable methionine, so a higher concentration of methionine flowing post-ruminally. As lactation progresses, we actually would formulate for lower levels of metabolizable methionine. And in fact, in very late lactation, there's an optimum level of methionine that we'd really like to try to hit. If we get lower than that, we see reduced production. If we get higher than that, we see reduced production. So it's a very complex and very dynamic system that we're trying to meet the requirements for. And for these reasons, many nutritionists have moved towards formulating with computer models to try to meet these requirements, potentially across different stages of lactation, to try to optimize feed and nitrogen efficiency. Another meta-analysis, this one was conducted using in France, using the French model, Sistali. They looked at the interaction between metabolizable energy and metabolizable protein. So metabolizable protein is the protein which is absorbed in the small intestine, and net energy is what would be available for lactation. And what they found was that for the production of milk, as we increase the net energy, we actually see, they saw, reduced milk fat production. And again, this is related to increasing energy density of the diet, not maintaining optimal rumen environment. The opposite was the case, and there was a fairly strong interaction in milk protein yield. As we increase metabolizable protein, we saw a greater response for higher levels of net energy, which corresponds very closely to what we saw with the meta-analysis in which starch was increased in the diet. So again, knowing the level of energy in the diet will dictate the response that we get for metabolizable protein in the diet. And again, combining these two different types of responses to evaluate an overall energy yield, we see again an interaction between metabolizable protein and net energy. In this case, we get the best response to metabolizable protein, best in terms of increased energy output per cow per day. The best response to metabolizable protein occurs with the higher energy density diets, whereas with the lower energy density diets, we get a more attenuated response to increases in metabolizable protein. So it's a very complex system that we're dealing with. Utilization of models has really contributed to improving our ability to maximize output and also improve or optimize feed efficiency. So I'll just take a brief moment here and sort of summarize the nutritional component of feed efficiency that I've discussed up to this point. As always, as nutritionists, we try to start with good quality forages. That's the basis by which we can produce really a high quality food for human consumption with something that humans don't want to eat and sometimes can't be, we can't grow human food on that landscape. supplement to increase energy density, but as I mentioned a couple times throughout the presentation, we want to do that while maintaining rumen function. And this comes from managing the access and the ability of the cows to sort the diet, maintaining optimum effective fiber in the diet. We want to meet rumen degradable protein and supplement with rumen undegradable protein to optimize metabolizable protein flow. But not only the protein flow, the metabolizable protein flow, but we also want to optimize the amino acids that's available at the small intestine to meet those requirements for lactation. And as I emphasized a couple times, adjust diets based on days in milk and potentially productivity. I know this isn't something that's often done on farms, but I think that we can build a more efficient system based just on optimizing the diet that we're feeding based on days in milk and level of production. So from the nutritional perspective, I think we're gaining a better understanding of how to formulate diets for improved feed efficiency, improved productivity. But there's also only so much we can do. There's every feed ingredient has almost every nutrient available to the cow, we just in differing components. So what we really are left with is trying to understand, the modifications we make to the diet we can only change so much, right? In often cases, if we look at the output that we get per unit input, oftentimes with nutrition, we're out here. We can get a response by, adding a little bit extra starch to the diet, formulating maybe for a little bit higher fat content, optimizing the amino acid flow. But on many farms, what we'd really like to see is, fairly big jumps in productivity, right? With very little inputs. This is where we gain the greatest efficiency, down here on the curve. This is what we see in many different systems, including milk production. There's diminishing returns. The more inputs we put, the lower our return that we get in terms of outputs. So what we'd like to do is look at what are the things we can do on farm that will give us this type of increase. And maybe on some farms, you're really well-managed herds, these won't be there. But on some farms, these might be the low-hanging fruits that really can take production to the next level. And then the question is, what can we do, not only to increase outputs in the system that we have, but what can we do to change the system to really raise this bar? And I'm going to talk about some of the things that we can do at this part of the response curve, but also some of the things that might raise the bar in terms of feed efficiency in the next couple slides. So I spoke about the nutritional factors, which is something as nutritionists, I always thinking about how can I optimize the diet to improve feed efficiency, make sure the cow is getting the most out of the diet that I'm formulating. But there are other factors to consider. This is a very interesting study that was published by Bach et al. In 2008. What they did was they studied 47 farms that were fed the exact same diet. And this was based on a co-op in Spain, so they were able to feed the exact same diet to all these farms with a similar genetic base, and able to determine what effect non-dietary factors have on productivity. And what they found was that these farms, even though they were fed the exact same diet, had a very similar genetic base, had productivity that ranged from about 45 pounds to about 75 pounds. So a 30-pound difference just based on non-dietary factors. Okay. They did a regression. What they found was 56% of this variation was explained by 4 different factors. Age at first calving, the presence of feed refusals, stalls per cow, and whether feed is pushed up. And so one of the things that my takeaway from this is that while the diet that they were formulated for was exactly the same, presumably the diet that was delivered to the farm was exactly the same, the diet that these cows received was not the same. So feed refusals, were they feeding to refusals? Were they pushing up feed? Did cows have access to the feed that they were given? Stalls per cow, were cows competing for lying time? Were they competing for space at the bunk? And then age at first calving, which I'll touch on a little bit more later. So just keep in mind that while we're trying to provide diets that optimize feed efficiency, there are many other factors on farm that contribute to changes in feed efficiency. And in fact, when we look at averages across the industry, we can see that we're getting improvements over time in both fat and protein for both Holsteins and Jerseys. But one thing to note is that while these averages are, I'd say, are very, very good, and obviously the trends, the increasing trends are good, if we look at what's available, these are actually pounds, not kilos. We look at the responses which are available to us by looking at the record holders in the last several years. We can see that the record holder productivity is several times greater than what we're actually seeing on average. So the genetic base is there. What we need to do is minimize the constraints or the bottlenecks that we see on farms. And just for your perspective, this is, some of these averages are over 400 servings of milk per day. So talk about changing feed efficiency. If we can have one cow produce milk for 400 servings versus the number it would take for these average farms, we're really improving the efficiency as an industry. So the question that we always have to think about is, well, where are we going? How far is it that we can go? This is our maximum cow now. This is where we are as an industry in the United States. Where are we going? Are we going to increase out to here? Are we going to increase up to here? What will it take to get here? What are some of the bottlenecks that are present in order to get there that will keep us from getting there? So can we get there? Is this achievable? The genetic base would suggest that we might be able to do that. What are the best cows going to look like when we get there? And then again, what will it take to get us there? When we look at some of the factors that we see changing feed and nitrogen efficiency, what we see is that in general, those increase in the same direction. So these would be the non-dietary factors that I mentioned before. Energy efficiency, nitrogen efficiency are both increasing. There's a positive correlation here. But there are also cases in which, we see increases in energy efficiency with increases in nitrogen efficiency and the opposite occurring. So it's not always the case that we're seeing them changing in the same direction. But I'd say overall, when we look at things like genetics, things like health status, when we see increases in nitrogen efficiency, we'll see increases in energy efficiency. So one of the areas where there might be limitations on farm is the genetic base. And the question becomes is, do we need to feed for a different genetic base? And so what we did was we looked at this. We segregated cows based on their PTA for producing milk, based on genomic information. And then we fed them 2 different diets. And we grouped them based on their low PTA all the way up through a high PTA for milk protein production, and then fed them the 2 different diets. When we look at the genetic variability within any farm, you can see even though we're trying to manage the genetics for the same criteria, we see a wide range in genetic predictions. This would be in the red. And the phenotype of these cows here in the blue, you can see there's quite a bit of variability here too. So we need to know that there's genetic variability and phenotypic variability contributing to our responses. What we found was when we fed these cows, these are first lactation cows, we fed them for 84 days. We fed them either an adequate metabolizable protein diet or a low metabolizable protein diet. We saw that increasing the genetic merit of the cows, we saw reduced body weight. So again, these are cows which we're not selecting for changes in body weight. We're selecting the cows for protein yield, and we see reductions in body weight for these cows. So these cows have lower maintenance out here, and that can contribute to their production of more milk and potentially in greater efficiency. Dry matter intake did not change based on the genetics, but we did see an increase dry matter intake when we fed adequate metabolizable protein, or conversely a reduction in dry matter intake when we restricted the metabolizable protein available to these cows. Now, for me, this was the really interesting part of the study. What we did was we were looking at the different levels of genetics, and we're trying to answer the question, do we need to feed these cows differently? They have different genetics, predicted genetic merit. Do we need to feed them differently? What we found was that when we look at milk yield, the cows fed adequate levels of metabolizable protein, they increased milk yield as we increased the genetic merit of the cows. But we actually blunted the genetic response based on feeding an inadequate diet. So what this tells me is that we really need to think about, are we feeding cows as a group? Do we need to formulate diets for cows based also on not only their overall productivity and maybe days in milk, but also on genetic merit for these cows? We saw a very similar response to milk protein yield, in which we saw increasing levels of milk protein yield with our adequate diet based on increasing genetic potential. But as we fed an inadequate diet, we saw a lack of expression of the genetic potential of these cows. So we were reducing the genetic expression of these cows based on our diet. From the efficiency perspective, actually there was no interaction between the two. We saw increased efficiency as we increased genetic potential, and again, we increased efficiency based on increasing metabolizable protein. And the same type of response here for nitrogen efficiency. So increasing genetic potential, increased nitrogen efficiency. In this particular case, increasing the metabolizable protein increased their nitrogen efficiency as well. So genetic potential and the genetic base of the herd will in some cases determine the feed efficiency of your ration, but potentially we might need to be feeding these high genetic merit cows a little bit differently to allow the genetic expression to occur. One of the biggest changes you can make genetically would be changing breeds. So this is a study that I've been playing around with, in which we're looking at the differences between Holsteins and Jerseys. These are all of the comparisons of Holsteins and Jerseys I was able to find in the literature. 30 published papers, 76 experiments between 1986 and 2018. And what you can see here is that when we look at megacals of milk, so milk energy, and the dry matter intake that was required to make that milk energy, we can see that the Holsteins were able to produce more energy, but they required more dry matter intake to do that than the Jerseys. In other words, if we want to produce the same amount of either nutrients or energy for human consumption, in this particular analysis, that required more dry matter to do it with Holsteins than it did with Jerseys. So just something to think about, as we move forward, as the industry moves forward, and we're thinking more about the genetics. One of the other things that can really limit the genetic potential or limit the expression of dietary differences is the health status of the animal. Now, we all know that we want to try to keep our herd as healthy as possible, but we don't always think about what's the energy impact or what's the protein impact that's having on overall feed efficiency. These are a couple of studies that evaluated that. Just very briefly, they infused LPS, which will activate the immune system. It's used experimentally to activate the immune system without actually making the cows, giving them an infection. And what they found was that an activated immune system required over 2 pounds of glucose within 12 hours. And you can see the response here. At hour 0 is when they infuse the LPS. They see a massive hyperglycemia after LPS infusion, followed by a very substantial hypoglycemia for the rest of the 12 hours. So a very disrupted glucose status within these cows. And of course, glucose is required for producing non-essential amino acids, producing lactose. So this has very important impact on overall yield and efficiency. A similar type of study, in this case with sheep, what they did was they also infused LPS, and these are the amino acids, concentration in plasma, and as you can see, the change from baseline is negative in almost all cases. So infusing an LPS, challenging with LPS or activating the immune system draws the amino acids out of plasma and away from potentially being used for milk protein synthesis. The very last non-dietary factor that I'm going to cover, so we looked at a lot of things that can impact the feed efficiency of cows themselves, the nutrients that the cow consumes and how that is produced into milk. One very last thing I'm going to talk about is whole farm efficiency and how that can be impacted by some of the management decisions. So one of the things that Alex Bach found in his analysis of those farms was that age at first calving was very important. This is cumulative efficiency for a theoretical cow. And we look here from birth out through 2 years of age, 2 lactations. We can see that for the first 2 years or so, there's no milk produced, right? However, that calf is still consuming dry matter. So this is cumulative dry matter or cumulative milk. And we don't start seeing any income or any milk from that cow until she calves. So by the time she actually calves, we have a significant investment not only of money but also of feed and of lost feed efficiency in this cow. It takes until about the beginning of lactation 2 for that cow to become an overall a net feed efficient animal, and that's only when she has a feed efficiency of 1 right here. Or said another way, feed efficiency is 0 for milk out until that cow starts her second lactation. Okay, now she's putting on body weights, which will have a salvage value when we sell that cow. But ultimately, from a feed efficiency perspective, cumulatively, we're not actually feed efficient until we get out here. So one of the ways we can manage this is to optimize this age at first calving and potentially change the diet that we're feeding to these heifers. Just 2 slides and then I'll conclude with your questions. Many studies have shown that optimized age at first calving occurs at between 22 to 24 months of age. If you get beyond that, you start to lose productivity, but more importantly, you're feeding that non-productive animal for longer. So this has a significant impact on overall feed efficiency of the herd. And that requires optimizing the breeding window here between 13 and 15 months of age. The other way you can impact feed efficiency not only is by optimizing the age at first calving, also by potentially changing the diet that we're fed to those heifers. This is a study that I did as part of my graduate work in which we fed heifers different energy density diets, but we restricted the feed that we offered them to maintain the optimal level of average daily gain. And what we saw was that in order to get the animals to a certain body weight, we had to feed significantly less feed to these higher energy dense diets than we did with the lower energy density diets. And the other thing we saw too was that there was a much greater spread. So the variability was much higher for these lower energy density diets than it was for the higher energy density diets. So in terms of the heifer program, thinking more holistically or more globally on farm, not only do we need to think about what we're feeding the cows, keeping them healthy, maintaining access at the bunk, improving the genetic base, but if we want to really improve farm efficiency, taking into consideration things like the heifer program, your forage program, are something that I think in the long run will help us out as an industry and on each individual farm. So I'll just conclude by asking, on your farm or on farms you work with is, what's your target? What are you trying to do? I've talked a lot about feed efficiency. Maybe maximizing isn't the goal, but maybe optimizing is the goal. Maximizing income over feed costs, this is always something that's very important. Increasing milk fat in certain markets is important. Maximizing profit, all of these things could be the goal of your farm or farms you work with, but it's just really knowing what that goal is and then taking steps in order to manage your herd in order to do that. So just some take-home messages. Providing the balanced ration is important, and really starting that with the high-quality forage to manage rumen environment and optimize feed efficiency. But it doesn't stop there, right? We don't want to just focus on the diet and forget everything else. So feed efficiency is affected by many things, not just the ration. So ensuring access to the ration, evaluating genetic tools and implementing those to improve efficiency, maintaining a minimal disease and minimum stress environment for those cows so that that does not take away from the productivity, and then consider the whole farm for improvements in feed efficiency. And the example I gave you was the heifer program. So with that, I'll conclude, and I'd be happy to take any questions that you might have.
questions for Geoff?
Any questions?
So I'll ask you a question. So what do you think will be the best opportunity for increasing feed efficiency in the near future?
The question is, what is the best opportunity for increasing feed efficiency in the near future? There's several options. I think the biggest one is, and it's always usually the most difficult one, is improving the overall forage base on that farm. I think that's something that, I think everybody recognizes that we need to have good quality forage, a good forage base, but it's always something very difficult to obtain, especially when we have weather intervening, when we have other management practices that might intervene. But I think overall, selecting for high quality forages, improving the digestibility, whether it be through low lignin alfalfa, BMR, corn silages, management practices such as increasing the chop height, all those things can improve efficiency, but then you have to answer the question whether it is improving overall farm efficiency as well if you're leaving stubble in the field. So I think there's many opportunities in the very near future. I think focusing on that forage base is always important. In the sort of intermediate future, looking at the genetic factors, improving the genetic base of the herd. That's always been something that has had a very long time frame, but as we're improving through the use of genomics, that's something that can allow for an accelerated improvement of the genetic base of each herd.
And long range, 10, 20 years out?
10, 20 years out. So if you're, I mentioned the difference between Holstein and Jersey. That would, looking at different breeds, that would be an option. Improving selectively or culling decisions based on really optimizing that the cow comfort, the stalls per herd. Really each change that we're making is going to have a cumulative effect on overall productivity and overall feed efficiency. So maybe any one of these is only going to change by a little bit, but as a cumulative whole, we're removing, continually to remove impediments to productivity and efficiency, and overall, over time, that's going to be increasing.
Any other questions?
Well, I'll be around, but thank you very much for your time. I know you're all very busy, but thank you.
Geoff, one more time.
You're trying to lead me somewhere. I didn't quite get.
No, I just wanted. I wasn't exactly trying to lead you, but I was trying to get at things they could do in the short term and then things. I wasn't going to go intermediate. I was just going to say and long term.